can then solve for my theta and my r. What do you think is theta equals to? What should theta be equals to for at this point here? Okay, if I use this equation here, u sine theta equals to 0. Okay, that means my theta can be two values, either 0 or pi. Okay, so if you can let's just assume, right, that the origin is the point D here. Okay, so I put origin here. So point B, right, if I want to measure the angle, remember how I define the angle? Where do I measure my angle from? Anyone remember? Positive x-axis, right? So it measures from this point to this point, right? So what is my point B's angle? It should be equal to what? 0 or pi? Yes. Okay, so my theta will be equal to pi. Okay, and when I get my theta equals to pi, okay, I can also get the distance, the radial distance that I want, okay, which is my source over my 2 pi. Okay? So this is quite important, okay, that you must know that for theta, right, okay, the stagnation point is always equal to pi. Alright, because it's at the front surface, okay, the frontal part here. Now, so what I've done, right, is that I now draw the axis for you. Okay, so you can actually find out that my distance, right, is just from this location here. Alright, it's my source over my 2 pi. So this one, right, tells me a few things. At the central point, okay, I know what is my theta, and I also know what's my r equals to. Okay, now if I want to find what is the stream function value at the central point, it becomes very simple. Okay, let me just go back to the previous slide. So the total stream function of these two flows is equal to this value here. That means, right, for any theta value, for any r value, I can find the stream function value. Yeah, remember what I say, you see, the flow, right, is going past the source, right? So every of this line here has a certain stream function value. Okay, because all of them are individual streamlines. Okay? Now the thing is, right, since I found where is my stagnation point, okay, I can actually find out the stream function at the stagnation point. Okay, the stream function at the stagnation point is simply equals to half of the source drag, that's all. Why is that so? Okay, you can see from here, right, at the stagnation point, my velocity is 0. So this first term will be cancelled off, right? At the stagnation point, my theta is equal to what? Pi. So if I have a pi here, I have a pi here, okay, the 2 pi's will cancel off, and that will be my source strength over 2. Okay, so this is a classical value, so it's a theory, right? If I want to find the stream function at the stagnation point of a uniform plus a source flow, it's always equal to this value. So therefore, right, we can say that since at the stagnation point, the stream function is equal to the source strength over 2, okay, we can then simplify this further, okay, by having this equation here. So what is r sine theta? Okay, so r sine theta, right, is actually your y-axis, right, your y coordinate system. So I can change my ur sine theta as my uy if I want. Okay, so therefore, right, at the end of the day, I can also find out what is my y equals to. Okay, now what is this y? What does this y tell us? Okay, this y just simply tells us, right, okay, the distance from the origin, okay, to the highest point here, the first point here where you have a streamline. Okay, so if this tells us the thickness, okay, of a ranking half body. Okay, because when there's a ranking half body, right, it's something like a shape here, right? So there's some dimension you must consider. First, where's the stagnation point? Second, right, the thickness, okay, of the ranking half body. Okay, so therefore, right, to find the thickness, it must be too wide because it's over the whole body here. Okay, so your h is equal to 2y. Yes. For ranking half body, yes. Okay. So this at this location, right, at this axis here, what is the theta equals to? If my point B theta is pi, right, that means on this axis my theta should be equals to what? 0, correct? So that means my theta can be equal to 0 here. So therefore, right, the thickness of a ranking half body is simply equals to the source strength over my velocity. Okay, so these two are quite important, okay? It tells us the characteristics of the ranking half body that we want. So by doing this, right, at the centration point, I know where's the location of centration point. I also know the thickness of the ranking half body that I want to find. Alright. So for this case, right, it's quite simple because it's just for a source flow. Okay, but let's say if I want to add this now, let's say instead of uniform flow plus a source flow, right, I can do for uniform plus a doublet. Alright, so eventually we can add this up more and more, right? Okay, until a point where it becomes a lifting flow. Alright, but I think for today I will stop here. Okay, I think it's more than enough for you guys already. So next week, okay, I'll finish this. Okay, I'll finish the uniform plus doublet plus contact also. Okay, then I'll do a bit of procedure. Alright. I know you guys got exams soon. So next week, right, I will just take 2 hours at a time. There's no tutorial for next week. Okay, so just come for 2 hours, and then I'll finish the lecture series for this week.